there's not a whole lot really to see here on that. And there's a, what do you typically call the control unit on any electronic system? This is the
PCM?
Yeah, you can call it electronic control unit, and you can call it electronic control module. There's a bunch of different ways you can call it that. And so basically, and this electronic control unit is, what's the purpose does it serve? Do you know? What do you need an electronic control unit for anti-lock brakes?
So it knows if you've applied the brake hard enough that it might lock up.
That's one of the things it looks at. That's right. How does it know the brakes are locking up? It's looking at wheel speed sensors. Wheel speed sensors are how it knows that it's locking up. It monitors the rotation of the wheels using electronic sensors, and when it senses that an ABS control wheel is going to stop rotating, it sends electronic signals to a hydraulic control unit. And I think there's one of those on that shelf behind Webb over there somewhere. But you've got isolation and dump solenoids. I've actually got some pretty good video on this that I may show you later that shows you what's going on during ABS stop. It doesn't take long. It's a short and sweet thing to go through. But one way or another, whenever it senses that it's going to stop rotating, the ECU sends signals to the hydraulic control unit, and they isolate that particular wheel from brake pressure in a sort of little bursts. In other words, they don't just completely block it so that it quits stopping, but they stop it from sliding. As it starts to, whenever it starts to roll again, they continue to apply bursts of pressure, basically. And a lot of the hydraulic, the rear anti-lock brakes, like on the Ranger that you had to put your ABS thing on, all they do is keep the rear wheels from sliding. They don't pay any attention to the front ones at all. That's why they call it RABs, rear anti-lock brake. There was two little solenoids up on that little proportioning valve. And when those two little solenoids were there, pick your head up, Roger. Whenever they were picking up those little solenoids, one of them is an isolation and one's a dump. So if the brakes are already stopped, the wheel, it's got to get rid of that fluid pressure so the wheel will start rolling again, right? And you're already applying the pressure, and it's trying to put pressure in there, so the isolation solenoid is going to block it so no more pressure can go there. The dump solenoid is going to dump the pressure so the wheel will start rolling again. Then when it starts rolling more than, to a certain point, it actually opens the isolation solenoid and lets pressure go back in there so that it's basically stopping. Now, when I was driving these, I had this Ford Probe one time that I was doing an anti-lock brake system repair on. The wheel speed sensors on a Ford Probe were like $200 a piece. It's a sort of a sports car, And so it's funny that the differences in anti-lock brake systems is what I'm getting at here. And I said, well, I'm going to drive this thing on this slick road out here going out to the airport. It's a wide asphalt road, no traffic anywhere. And I said, I'm just going to see if these ABS will work. And the speed limit on that road was about 60 or 55 or something like that. So I went up to the speed limit, and it was raining like it is today. I mean, the pavement was just as slick and shiny, and the car had good tires on it. It was good shape. And I just hit that about the speed limit, and then I just stood on the brake as hard as I could. A panic stop, like when you're trying to keep from hitting somebody's pulled out in front of you. And that car, it just went boom. It stopped like it was on dry pavement. You couldn't feel nothing on the pedal or nothing, but it stopped. And it's counterintuitive because you're thinking this thing's gonna slide and lock up and go all over the place, but it didn't do that. That's what anti-lock brakes are about. Have you ever locked the brakes up and sliding all over the place? It scares the daylights out of you because you feel like, oh no, I'm not gonna be able to. Sometimes when the wheel starts sliding, it picks up speed. You ever notice that?
Yeah.
I mean, if you've been even on ice or whatever. Okay, now the other part of it, Jeep Cherokee, 4-wheel drive. I'm working on the ABS on one of them. It's a different type of ABS, but it's not sports car ABS. You get on a dirt road over there to check one of them to make sure that the ABS is going to work, because I don't want a customer complaining and say my ABS didn't work right. So I go over here and I get to going about 25, 30 miles an hour, and I stand on a brake, and it's like a bucking bronco. But on the sports car, it was real. See, that all ABS is not created equal. That's what the purpose of those stories is about. All right. It uses controlled hydraulic valves to modulate the hydraulic pressure sent from the master cylinder, the wheel cylinders, or the calipers. And pressure of the brake shoes or the pads is reduced, and it prevents the wheel lock up. You got steering control when your wheels aren't sliding. That's the long and the short of it is. And ABS makes better braking performance. It reduces vehicle speed in the shortest possible distance if you're on road surfaces. Now, if you're on gravel or something like that, it's not. And Okay, so on most ABS systems, the driver will sense the pulsation in the pedal. Now, one time there was a guy that, a Thunderbird over at Lincoln Mercury that went in there. It might have been a Cougar, and the little pulse ring that the sensor read off of on the wheel was just a little. It was kind of pressed onto the rotor, and it had come loose. And sometimes when you go to hit the brakes, that pulse ring would dance around because it was loose on there, and it would stop turning, and it would fool the ABS computer, ECU, into thinking that you have a wheel locking up, and it would start blocking the brake fluid going to the wheels, and you would still be going, and you feel a pedal bouncing under your foot, and it just goes on through the intersection. That scared the living daylights out of you. And there was some issues with that in the early 90s that they had to deal with. It was scary as all get out, but I never heard of anybody having an accident like that. Now, let me fire up my little sheet here. My thing. I am going to show you a picture here that's pretty cool. All right, so this right here, you're going to notice, it'll come up there in just a second. That's your operational overview. All right, you see how that, the way this thing is drawn, and that thing will wake up in just a second and start giving me a picture. The way that thing is drawn, you're basically looking at whenever fluid is allowed to flow is designated by the two arrows, and when it's not is when you're blocked. You got me? All right, and so you got an inlet / isolation valve. When that's open, see, you got pressure going there. And we got a dump valve, and it's closed. That's normally. This is the normal state of these two solenoids, these two valves. All right, there's an accumulator up here. Did anybody know what an accumulator does? Anybody got any idea what an accumulator does?
Accumulates a bunch of fluid.
Well, that's just taking the word that you're looking at.
Expansion for.
Anytime you've got an accumulator, you're basically going to have fluid pressure going there. It's going to squeeze a spring. And if you got an accumulator, think of an accumulator as a cushion. An accumulator is there so that whenever this pressure goes up here, it doesn't go. Because pressure can hit as hard as a fist or a hammer or something like that. So basically, if you've got a cushion in this circuit somewhere, it's going to squeeze that spring, and when it goes back to, whatever it acts on other things in that circuit, it's not going to hammer. It's going to go more, because that spring is basically like that. Anytime you've got a spring, you're basically got it there for cushioning purposes, and that's what an accumulator does. Transmissions have those to soften the application of the gear, so that it doesn't jerk a crick in your neck when it shifts gears. They want it to apply nice and firm, but not so, firm that it's, rough. All right, so everybody knows you got your master cylinder here. The pressure's coming this way. This is a beautiful little illustration of what I'm talking about. And once again, this is a normal state of those. These begin to change whenever you get into that. Okay. All right, now I'm going to go on down here to another, if I can go to my next page there. All right, you see that right there? Now look what's going on. Initially, if you're holding pressure at the brake caliper, notice this one here is closed now. No fluid can pass through it. That one out there is still closed, and there's pressure being held there. All right, there's your brake pressure hold situation. This is all happening in nanoseconds. And if you've got different, network buses on these vehicles, your ABS, your vehicle dynamic stuff, and your engine control is always going to have the fastest bus that's operating on. So just remember that. Okay. Now this right here is brake pressure decrease. That's what's going to happen whenever you're. You notice now this is still closed, so no pressure can make it to the brake. When it's decided that you're sliding and it doesn't want to slide, it's actually going to open that one. Now, a lot of times you can't even see these solenoids well enough to tell what you're looking at. But what's going on inside of them is what we're seeing right here. This is like a cross section. All right. And look, once again, this is a public domain thing that came from Ford, that I'm using right here. Okay, right here, and we got your pump and motor running. Oh, now look here. In a situation like this, you've actually got a pump and motor, and that pump and motor is going to kick on when pressure is required, but it can't count on you to put it in there. See, the pump and motor is used in traction control systems too. Like whenever it's going to stop the wheel that's spinning and force the differential to drive some of the torque over to the other wheel, that pump and motor is really important. So, now once again, this is the 4-wheel anti-lock brakes. Willie, the one that you put that little solenoid on the other day doesn't have a pump. On these Chevy pickups that we've got out here, just about every one of them, you'll see that big old ABS unit with a pump motor on it and all that. You know, that's kind of like what we're talking about here. All right, that's pretty well all we need to, that's the picture. I'm going to kill that right now. All right, so let's turn the camera back around here. All right, now then, that was the operational flow chart. Okay, well, I was a dummy. I need to fire that thing back up because I got to show you traction assist operation. And I can do that in a minute. It's probably going to need to cool off. I can talk about it because you know what we're going to do. Basically, it's going to fire up your pump, and it's going to, without you hitting the brake or anything, it detects wheel spin, right? And when it detects wheel spin on a wheel like on the right rear, like in your wet grass or whatever, and it starts spinning that wheel, then it's going to put brake pressure over there automatically. Have you ever had a pickup truck on the lift? And I'm sure some of you probably haven't. If you've got a bearing noise that you're looking for in your rear end, then you know it's one of your axle bearings, you know, like in a regular pickup, an old kind of pickup. And you happen to have that thing hanging on the lift and you're driving the wheels, and you got your stethoscope and you're listening while those wheels are spinning, and you say, well, now my right wheel is spinning in the air and the other one's just sitting here, and I really want to listen to the other one too. This is not acceptable. See, let's just say we've got a truck that's not a positive traction, whatever. So I'm going to reach over here and I'm going to grab the park brake cable going to the wheel on the right side. This is a naked cable anyway, you know. Grab the park brake cable, that stops the wheel on that side, and the differential then begins to deliver to the other side. That's the way traction control works, except it's not using a cable, it's using pressure that's applied. Got me? All right. Okay, so the traction control is utilized up to 35 miles an hour. You got me? Beyond that, the PCM reduces torque at the wheels using the powertrain control module. If you're going faster than 35 miles an hour, it's actually going to, you know, some of them have got closed, they got 2 throttle plates. Over there somewhere behind Webb, I've got a throttle body that came off of a Lexus, and it's got 2 throttle plates. One of them you might think looks like a choke, and the other one is a regular throttle plate. And if you're spinning the wheels too much, it's going to close that upper throttle plate to slow you down. Nowadays, like on my pickup, and on these other later model vehicles, you're going to, like obviously on Webb's shiny brand new sparkling white Chevrolet that he drives, it's going to have this throttle plate that's controlled by the engine controller anyway. And if he gets to spinning his wheels too much, it's the engine controller says, okay, this guy's driving like an idiot, so I'm going to, you know, close the throttle plate a little bit because he's spinning the wheels too much, and there's no point in spinning the wheels. You know what I mean? So he slows him down a little bit. The PCM controls the ignition, emission, fuel systems, and a bunch of other stuff. It's going to detorque and detune the engine enough to keep the wheels from stop them from spinning and all that. So, all right. So we're going to identify some components here. You know, basically, we're just be talking about those. Basically, you know the little wheel, the little toothed wheel. How many guys got rotors or CV axles or something? You see them little toothed wheels on them. So right there, the little toothed wheel that the ABS, you know, goes against. And let me tell you this briefly. Not all 2-wire sensors are variable reluctance sensors. Now, you know the signal, and you got a, incidentally, you guys have got a worksheet on this. And, you know, we did a lot of intense cleaning up last week, but we got to get back on our worksheets because we're supposed to be learning things here. Ordinarily, a wheel speed sensor signal is going to look like that, more or less, you know. Now, this right here, invariably, somebody's going to want to cheat and say, well, I know what they're going to look like. I'm just going to draw it on here, but I want you to measure it, okay? And so you can tell what it looks like. On that Dodge Caravan that Mr. Hutto drives, it has got a 2-wire sensor going down there, and it's got a 12-volt wire, and it's got a ground wire. And basically, as those little teeth go past that one, this is a Hall effect unit. And what does that mean? It's putting out a square wave signal. Are you sleeping? But, it's got a square wave signal, right? So instead of putting this out, and the problem with this is you guys all know, we got a little more into this in electronics. You know what amplitude is? That's how tall these humps are. And you know what frequency is? That's how close together the humps are. So the faster you spin the wheel, the taller the humps get, and the closer together they get. They both happen at the same time. Got that? Okay, now then, here's the other part. As you slow down, this signal right here begins to look more like this. And that's a little bit of a problem, especially if you're wanting to look at, if you're doing parking lot maneuvers, you're going to want a signal that's a little bit more reliable than this silly thing that flattens out as you slow down. Well, on the ones that, on that Dodge Caravan, they actually look like this. And even when you slow down, real slow to almost a complete stop, that little Hall effect is still going to switch on and off. That's pretty cool, isn't it? And they claim, and it's like a 7 to 14 amp or milliamp switch, you know, on this red wire, if you're measuring it on the 12-volt wire. But you can take a doggone voltmeter and hook into that 12-volt wire and turn that wheel and see that thing changing. So you can tell if it's working that way. You know, do you understand what I'm saying?
Is that like because it's doing like open circuit, closed circuit, open circuit?
Yeah, pretty much. And you're basically going to see the voltage deflect just a little bit. You don't have to have any tool that's all that special. You can put a scope on there and actually see that square wave. Or you can just put a $10 voltmeter and put in there. And you turn that wheel through, you'll see it changing. It'll deflect in that. And you can tell if it's working or not. When you stop, it'll quit deflecting. Anyway. One way or another, it has to know what Sean said earlier. It has to know that when you're applying the brakes, right? Now, some of these, the vehicle dynamic system will even have Mercury switches, so that it can tell if you're pitching or yawing. You know, they've actually got a switch that's going to tell you if you've got something going on with it. It's measuring the latitude and all of the vehicle. It's pretty important. But remember now, the ECU calculates wheel speed, estimates vehicle speed since his impending wheel lockup, and it activates anti-lock brake, performs self-diagnosis. It's constantly looking. Tell you how that works. All right, if you wake up, let's say that you are Mr. Engine Controller, and you've got, you know, all these sensors out here. I'm just going to draw 3 of them, and each sensor is supposed to have, you know, something like, you know, 1,200 ohms or something like that, because that's fairly close. Some of them will have 2,000 and all that. All right, so, and then you've got these solenoids that you got out here that you got to deal with. I'm just going to draw 2 of those. All right, here's my engine controller right here. Okay, it's got power coming in, and it's got ground. All right, and it's got every one of these hooked up. And basically, I'm sort of not drawing this right because there's actually a relay that's going to, you know, feed these solenoids. But one way or another, what it does is, inside of its circuitry in here, it's basically going to send a little whisper of voltage out to each sensor and each solenoid, and every circuit's supposed to be closed. If it hasn't grounded that, if it's not actually using that, it's just sending that voltage out there, and it doesn't see something coming back on the other side, it's going to throw a code. Got me? Like if it knows that as I'm shooting 12 volts out on this one and that one and this one, and I mean, I ought to see it coming back on that side. May not be 12 volts, maybe 5 volts, whatever it decides to send out there. But it's going to shoot that out there, and whatever comes back is what it's going to tell it if that's a good circuit or not. And so that's really an important thing to understand. If I'm getting an anti-lock brake solenoid code, what I'm going to want to know is if I unplug this connector and I go right here and I feed some voltage into one of the wires going out there, am I going to get it coming back? You see, or maybe on a wheel speed sensor or something like that. I'm going to unplug it, find the appropriate 2 wires in the cavity, and I'm going to measure it with my meter. That's how you do that. Anyway, it stores diagnostic trouble codes when a fault's detected. Now, the hydraulic control unit is the big ugly part that's got all the lines going to it and got the motor on it. And it's got a low pressure accumulator, a high pressure accumulator, inlet port, outlet ports, inlet isolation valves, outlet dump valves, hydraulic check valve, control valves, traction assist valves, valve control solenoids, and you know, some of them may be in the engine control, electronic control unit. Most newer vehicles combine the ECU and the HCU, which would be hydraulic control unit and electronic control unit, into a single assembly. And that consists of an ECU and an HCU that are bolted together. If you ever run into a situation where the ABS unit won't talk, or any other electronic unit won't talk, one of the first things you're going to do is find out if it's got power and ground feeding it. If it's not powered up, it's not going to talk. If it does have power and ground feeding it, and the wires going to your scan tool port are good, then you got a bad unit. And that happens too. All right. Now then, let's see here. Okay, the low pressure accumulator is located in a valve body. It temporarily stores purged fluid from the wheels. That's what it's for. It's normally empty. The pressure is also used to prime the pump. And at the end of ABS stop, the low pressure accumulator is normally drained back to the master cylinder. The high pressure accumulator is in the valve body. And it stores hydraulic fluid under pressure to be used during reapply. It fills the anti-lock brake control module and turns on the pump. Alright, and then your pump's driven by, usually there's two wires going to that pump motor. It may create more pressure than demanded by the driver, through pedal input. If it needs more pressure, it can produce it. You see, that's the point. On some ABS systems, the pump motor can be serviced separately from the HCU. Now, your wheel speed sensors, every ABS control wheel has a wheel speed sensor. Now, there's a little bit of a difference there. Listen to this. On the Chevrolets, like the GMC that we've got out there, it uses the output shaft sensor going out the drive shaft to tell what the rear wheels are doing, and it controls them collectively. That's why you call it three-wheel ABS, because it's actually the whole rear axle is controlled at one time. The front wheels are controlled separately, but on most of your vehicles, it'll have every wheel will have a sensor on it. Alright, so wheel speed sensors is hardwired. Now here's something else. Let me tell you this while I'm thinking about it. When you turn the wheels back and forth a lot, every time you turn the wheels, you're bending those wires going to those ABS sensors. If you see an ABS sensor that is giving you like a code for an ABS sensor, to begin with, make sure that your goofy scan tool is not lying to you about which wheel it is. We used to run into that sometimes. Even whenever I was at Ford, we'd have the Worldwide Diagnostic System or IDS or whatever we happen to be using. And it would tell me that the right wheel was the left and the left wheel was the right. And boy, if you're trying to troubleshoot one particular wheel, that'll just throw you for a loop. And make sure it's telling you the truth. I've had this one here tell me it was the left wheel when it was the right. This Genesis scan tool that we've got in here, I've had it lie about which side the wheel is. I don't know why that gets confusing to the people that type those software, but it does. The sensor, the variable reluctance sensor, creates a magnetic field. Remember how that works. You got a magnet, you got wire wrapped around that magnet. Every time a tooth goes by, it shifts the magnetic field in that little magnet, and when it sweeps across those windings, it creates voltage from scratch. See, that lets the ECU count the teeth on the wheel speed sensor as they pass it, right? And the G switch is used on some four-wheel drive vehicles. I think you got a question about that, because all four wheels are mechanically linked. You got me? That makes it possible for a lockup at any single wheel to cause all four wheels to lock up. So without some way of detecting vehicle movement, and that's what I'm talking about, the way the body is rolling or whatever, the G switch is to detect vehicle movement. So it'll know if you're going back, forth, if you're actually stopping, in other words, if you're stopping or rolling or whatever. When the vehicle is at rest or moving at a steady speed, Mercury contacts all three terminals in the G switch. Reference voltage is sent from the control unit through the center wire, and the voltage returns to the ECU through the two outside wires. And you guys seen a Mercury switch before? What do you think about a Mercury switch? A Mercury switch is basically a little bulb that's got mercury in it, and you'll have two wires in the other end of this little bulb. Burglar alarms use it. And whenever somebody raises a window, it does this, and whenever that mercury swashes over here and covers those two terminals, it closes the circuit. See? And now, how many of you ever opened the hood on a vehicle and had the hood light come on and you wondered why? You ever seen that? There's a mercury switch in that under hood light. And on your trunk, a lot of the times, you'll have a mercury switch.
I think mine broke in my
Yeah, well, if it's broke, you'll probably have the light on all the time, but the long and the short or never on. Okay, so what happens here, as the vehicle starts to decelerate, the inertia switch, inertia causes the mercury to move toward the front of the switch, and it breaks the contact between the rear terminals on the switch. If the rate of deceleration increases, the mercury is forced further toward the front, and basically it breaks connection with all the terminals except one. And toward acceleration, the mercury moves to the back of the switch. So that module is smart enough to know when you're really getting on it or when you're letting off. You see, it's pretty important stuff. And so, for the most part, you know, you're basically, you guys know how this, how you find something that's wrong, right? How do you find something that's wrong whenever you're doing something on any car? You're going to start with your symptom. The symptom is that I've got a light on, this don't feel right, my pedal's bouncing, whatever. Got me? Or my ABS don't work. That's your symptom. The system is going to be, you're going to isolate it. Okay, so what system is this pointing me toward? Okay, it's pointing me toward the ABS system, which entails all the stuff I've been talking about. The hydraulic control unit, the wheel speed sensors, hydraulic brake system, you know, everything. And then you're going to narrow it down as you do your troubleshooting to the component, the actual component that you're coming down to. And then finally, when you get to the end of it, you're going to find out the cause. You're going to actually isolate it to the component, and you're going to find out what's wrong with that component. And then you basically, you know how to make that work, see? And so, but what do you have to do in order to do this stuff? The symptom is basically something that the customer is going to give you, right? Okay. The system is something you've got to know a little bit more than most of the customers in order to make it to the point to where you're at the system level. You know, it could be this system or that system or the other system. Like, for instance, on this Toyota out here, Alan opens the hood on the car and he goes, I'm hearing a noise that I can even hear inside the car. He's got no other symptom except I'm hearing a noise, right? Okay, so this is an extreme example of this, of shortness of troubleshooting, but I raised the hood, and as soon as I look down there, I'm hearing this, you know, growling, rattling kind of a noise. And I look down there, and I happen to notice, just because I've gathered some data with my eyeballs, that the windings in the alternator are all discolored and burned and all that kind of stuff. And I said, you need an alternator. Well, see, I went all the way from symptom to system to component to cause. That quick. You see what I mean? It doesn't always happen that quick. Sometimes there was a noise that this one vehicle was making. This boy brought his vehicle in here. He was actually a former student, but he was working at his dad had a tractor shop, and he's working over there. And he had a Chevrolet pickup, and he says, I have changed all of these pulleys and all that stuff and put a power steering pump and blah, blah, whatever else he did. He put a bunch of pulley stuff on there. While he was there, he bought a new belt. Hand me that belt right there. And so he buys a new belt. And so I said, okay, let's take the fan off. And let's see if the noise is still there. He had a symptom, which was a noise. All right, we took the fan off so we could listen to this noise without the fan blowing air everywhere and trying to cut our fingers off. Got me? On that one, you could take the fan off fairly easy, but screwing it off, the pulley would stay in place. I got to listening with my stethoscope. I'm gathering data. You see, that's how you find out what's wrong with it. Pick your head up, Roger. And so, yeah, I was using this thing with a listening pipe. And I'm sticking it down here real close to where the pulley and the belt touch. And I'm hearing it's a whining. See where I'm going? All right, so watch this. This belt right here was the kind of belt that he had. See that strange belt? It's a shiny looking strange belt. Those things right there will make a noise, and you will swear you got a bad bearing or an idler or something like that. And Adam, this boy that that I'm gonna have substituting for me when I go to KC Vision in March, he called me from the place he was working one time about 4 years ago. And he said, I put a power steering pump on his van. And he goes, this is making a horrible whining noise. He said, I swore it's a power steering pump. And I said, yeah, I've been there. And he says, I'm really sort of bumfuddled about this. I said, what's your belt look like? Is it one of those kind that's got little flutes across it, but they're real shiny? They have some that are sort of fuzzy looking. That's a shiny one when it's brand new. He said, yeah, that's what's on it. And I said, put a regular Gates belt on it with this fuzzy, and you won't have that noise anymore. And he changed it out and it fixed it. And since then, I've seen that probably a half a dozen times. Somebody talking about, I've got horrible bearing noises or something. That stupid belt's all that was wrong with it. And Zach Beck had his mother's Jeep in here going, yeah. So when I looked at it, I saw that kind of belt. We jerked the belt off, quit, put another belt on it, quiet. See, so what I'm thinking is sometimes I've actually seen belts cause them to knock. I mean, sound like the engine was knocking, the old V-belts when they have chunks in them. Anyway. But one way or another, that's how you're going to do it on any vehicle, any lock brake system, anything you work on, you're basically going to do that. you're basically going to start out with a symptom, system, component, and cause. Okay. Now let's get up here in the brake master cylinder inlet ports number 1, pump motors number 2, solenoids number 3. Number 4 is a valve body. Isn't that interesting? You got a valve body on there, like you're talking about a transmission, right? Control valve. And finally, you got your outlet ports.
Number 1.
Number 1 was the brake master cylinder inlet port.
What was 5?
5 is the control valve.
Okay, wait, that's wrong. Still. You said number 5 was a control valve?
Yeah.
Number 4 was
Valve body.
valve body, and number 6
Number 6 is outlet ports.
outlet port.
That picture is not really that good. That's one of the reasons I'm spoon feeding you those answers. Okay. Now then, can you draw a circle around the wheel speed sensor and wheel speed sensor indicator? You got that? The wheel speed sensor and number 6. The wheel speed sensor and the wheel speed sensor indicator is where?
Right there,
On the far left, you got a wheel speed sensor. Very far left, right? Okay, the wheel speed sensor indicator. You see the hub with the lug bolts. That little ring that's pressed onto that. That little ring. There's a little ring on that axle, just a little ways from the hub.
this guy right here, right?
That's it. That little ring. That's the one.
Okay.
That little ring.
I see.
Point it out. Let me know. That little ring. Everybody know where? Everybody gets that, right? Okay. Okay. Number 7. What does a G switch do?
To detect vehicle movement.
That's a good answer.
Well,
Well, see, without some way of detecting vehicle movement, the ABS wouldn't be able to differentiate between, if all 4 wheels locked up, which they're going to if they're mechanically linked, it needs to know if the vehicle's moving or not, if the wheels are stopped. Got me? See, if all the 4 wheels are locked up, but the vehicle's moving, it knows it needs to do something. You get where I'm going? If the wheels are just sitting still and it's not, and it doesn't know if it's moving or not, it may try to activate ABS when it don't need to. So vehicle movement is actually, that's another input that the thing needs so it can know when a 4-wheel drive vehicle is moving. Okay. All right. So number 8. What's number 8? Somebody read number 8 to me.
if the driver gets into a situation where the brakes are applied hard enough to cause their wheels to lock up, what happens?
What happens in order? Can anybody say that?
I think signals go to ECU, ECU regulates HCU, HCU in conjunction with ECU regulates pressure, and brakes adjust.
Yeah, he's thinking, isn't he? ECU is going to determine which wheel is going to lock up based on deceleration rate of the wheel. It's going to send an electrical signal to the hydraulic control unit. That activates the solenoid, that causes things to happen. I mean, it changes the hydraulic flow. And that cuts off fluid flow from the master cylinder, preventing any more master cylinder hydraulic pressure from reaching that wheel. It's basically going to stop that wheel from receiving pressure, and it's going to dump the fluid that's there so that it will roll. And then it's going to hammer it back in there as it needs it. You can figure that out. Yeah, that's 4. Okay, it's going to determine, let's see if we can shorten those. It's going to determine which wheels in danger are locking up. It's going to send an electrical signal to the ECU, and that activates a solenoid that controls the inlet/isolation valve, and then that cuts off the fluid flow. And like I say, it lets it come and go. 9, we got one more question left after this. What are the HCU's pump and motor used for during an ABS event? Okay, since brake fluid is released each time the outlet dump valve is open, there's got to be a way to replenish brake fluid to the system. Got me? That's accomplished using the pump and motor. When the pump and motor are running, brake fluid is stored in the accumulator and it's pumped back in the master cylinder. Okay, and then hydraulic concerns will not set a DTC. Hydraulic concerns will typically not set a DTC, diagnostic trouble code. All right. You can get so. Will not. You're not going to get you won't always. Now, you've got the closest thing you'll get to a DTC when you got a hydraulic concern is if you're out of fluid or if you're low. it's gonna turn the red light on and it may send you a code in that way, but if you got some other kind of a hydraulic problem, you're not gonna.
I'll bring it on Tuesday on that one.
Anybody got questions on that? Yeah.
Right foot is